Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from A70 Malaya. Our topic is evaluating long-term benefits based operational risk of electric vehicle (EV) operation in hot and humid climates. Now, I would like to introduce my group member. First is Ahmad Izzuddin, our director. Second is me, Muhammad Iman Bisafizan, as the project manager. Third is Syarif Iqbal, which is planning engineer, and fourth is Jazlan Zainuddin, which is senior engineer.
For the introduction, the adoption of electric vehicle is a crucial shift towards sustainable transportation, but operating EV in hot and humid climate pose unique challenge, particularly regarding the safety and reliability of lithium-ion batteries. The risks associated with LIB usage, such as thermal runaway, mechanical damage, and electrical overload, underscore the importance of proactive safety measures to prevent and mitigate fires. There are multi-phase challenges and opportunities in ensuring the safety, reliability, and sustainability of EV power by LIB necessitated continued research and collaborative effort to advance the EV industry towards a greener and safer future. For the problem statement, the incident of a Mercedes-Benz EQB SUV catching fire while charging at a car showroom in Tampoi, Johor, highlights a critical issue in the operation of electric vehicles in hot and humid climates. The electric vehicle charging system operate without a license from the Energy Commission raised concern about the regulatory compliance and oversights in the deployment of infrastructure. For the objective for this project is first one is to assess the impact of hot and humid climate on the safety and performance of lithium batteries in EVs. Second, to evaluate the effectiveness of current mitigation efforts by OEMs to address the risks associated with lithium ion batteries in EVs. The third one is to analyze the long-term benefit of EV operation in hot and humid climates, considering environmental sustainability and energy efficiency. For the fourth objective is to identify the strategies to enhance the safety, reliability, and efficiency of lithium-ion batteries in EV operating in challenging climates. Next, we move to the methodology. For the methodology, I will discuss about the flow process for this project. First one, we start problem statement, focus subject, methodology, data collection, and data analysis. For data analysis, it consists five, which are evaluation, risk on EV battery incident, performance data on off EV operating, analysis case study on real world case, technical feasibility and potential, PMS and thermal management technologies. So we propose for enhancing safety measure and mitigation effort for the long-term benefit of EV operation, discussion, and the lastly is conclusion. This is some specification for Mercedes-Benz EQB SUV. For the body style, it is SUV. For the battery capacity, it has 66.5 kilowatt hour. For the charging time, it uses DC fast charging, abso- as- approximately 30 minutes, 10% to 80%. For the price, starting around RM 250,000 ringgit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Jazlan. So right now we'll present about analysis thermal runaway and battery degradation of electric vehicle. So the thermal runaway in lithium ion battery in electric vehicle, there's a formula which is including the thermal runaway equals to Q generated minus Q dissipated over Cv, which is the Q generated is the heat generated by the battery, while the Q dissipated is the heat dissipated by the battery, and the Cv is the heat capacity of the battery. Meanwhile, to determine the Q generated equals to I square times R internal resistance, which is I is the battery current and R is the internal resistance of the battery. Meanwhile, for the Q dissipated can be calculated by using the formula, which is Q dis equals to HA times TB minus T environment, which is H is the heat transfer coefficient, A is the surface area, TB is the battery temperature, and T environment is environmental temperature. And also the battery degradation rate can be found using K equals to AE uh, uh, to the power of negative EA over RT, which is K is the degradation rate constant, A is the pre-exceptional factor, and EA is the activation energy. Meanwhile, for R is the universal gas constant, T is the temperature in Kelvin. And what the information that has been shown to you is the assumption that we have made based on the article or the research that we have found. So, based on the information, which is the charging current, internal resistance, battery heat capacity, battery surface area, heat transfer coefficient, and so on. So, we made some calculation regarding the case happened on the Mercedes in Tampu Johor. So, since in Tampu Johor is the climate is hot and humid, so we make some assumption, and from the calculation, we calculate the Q gen, and then we obtain 25 watt, and for the heat dissipation we obtain 100 watt, and thermal runaway we obtain negative 0.075 kilo Kelvin per second, and the battery degradation rate is equals to 0.00045 second.
Next, for the analysis of total estimate loss. In this section, we assume the value of destroyed assets for Mercedes-Benz EQB SUV, which is $70,000. This value is based on the references and the sources from Car and Driver 2024. All of this assumption is based on the data that the sources of Car and Driver 2024 give. And for the cause of fire, we assume the fire was caused by a thermal runaway event in the battery, potential exacerbated by the lack of a proper BMS and thermal management system. Then, for the estimated losses, the total losses will include the value of the destroyed asset and the potential fines or penalties for operating without a license. For the thermal management cost, system cost, we assume that the value is 1,500 per vehicle and the advanced DMS cost is $500 per vehicle. All of this based on the car and driver sources. After the assumption that we get from the resources, we convert the value of the dollar into the ringgit nation, which is $1 equal to RM 4 ringgit 70 cent. So the value of destroyed assets we get is for Mercedes Benz is equal to RM 329,000, and the showroom building structure is equal to RM 470,000. For the electric vehicle charging bay, we get the value is RM 47,000 ringgit Malaysia. So the total asset loss is about RM 846,000 ringgit Malaysia, and the potential fines and penalties that we assume is about RM 235,000 ringgit Malaysia. So the total estimated loss is about RM 846,000 ringgit Malaysia for the asset loss, and the fine is about RM 235,000 ringgit. The total of the estimated loss is about RM 1081,000 ringgit Malaysia. In this section, we show the summaries of cost benefit analysis for all of the aspects that we calculate, and the value has been stated in this slide presentation. Lastly, for the analysis, we can see that the impact of temperature and humidity on battery performance is high ambient temperatures and humidity exacerbate heat accumulation within EV batteries, and it is elevated temperature accelerate battery degradation, reducing lifespan and increasing failure risk. For the benefits of thermal management technologies from this analysis and the advanced battery management system, TNT and advanced BMS offers significant advantages in EV safety and performance, and they prevent catastrophic incidents like fires or explosion by maintaining optimal operating conditions. And next, it also advanced BMS enhance safety through precise monitoring of battery parameters like voltage, current, and temperature. And next, it also balancing cell charge and managing state of charge instead of heat prolonged battery life. And lastly, for financial, the potential saving from avoiding such incident can be substantial, illustrating the cost effectiveness of investing in this technology. Thank you.
Okay, thank you, Muhammad Nurima, for the presentation. Now we will continue the presentation with the conclusion and recommendation. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zudi bin Ahmad Shukri. So, for electric vehicle EVs struggle in hot and humid areas. The Mercedes-Benz EQB SUV battery fire demonstrate the danger of lithium-ion batteries in such environment, emphasizing the importance of sophisticated temperature management and battery management system (BMS). This enhancement can help to reduce thermal runaway and increase vehicle dependability. As demand for sustainable mobility rise, effective risk management becomes increasingly important. Modern BMS and thermal management system may improve safety, comply with environment requirement, and increase customer trust, resulting in faster EV adoption and cleaner future. High temperature humidity rise the possibility of thermal runaway and battery damage. While the modern thermal management and BMS system are initially expensive, they provide long-term benefit like as increased dependability, extend battery life, and cheaper maintenance costs. Investing in this solution is critical for safe EV operation and being competitive in sustainability-driven industry. These solutions are configurable given current technologies and law, but they may costly and difficult. Continuous breakthroughs in battery technology and thermal management are critical, and regulatory agency must adapt to guarantee and perform requirements stay up with technical advance. Now we continue with the recommendation. First, investment in advanced technology. OEMs should continue to fund research and development of improved PFF and heat management technologies. Second, regulatory alignment. Collaborate with regulatory agencies to develop standards that ensure EV battery safety and dependability in a variety of environmental sectors. Third is education and training. Provide intensive training for stakeholders on battery safety and maintenance method in order to successfully reduce hazards. Fourth, the natural science understanding. Get a truth how understanding of battery chemistry and physics in order to grasp the foundation of thermal runaway and deterioration in lithium-ion batteries. This underlying information help to create effective mitigation method. Fifth, engineering fundamental. So develop technical concept to provide strong thermal management system and improve BMS for EV batteries. This ensures safety and dependability in variety of operating scenarios. Last but not least, engineering specialist knowledge requires specialized understanding of battery technologies advanced and safety regulation. Stay up to date on cutting edge research in EV design production. So that's all from our group T T70 Malaya. Assalamualaikum.